Hi students, in our previous session on reflection, we had discussed about the ray diagrams formed by spherical mirrors. And in this session, we'll be discussing about the mirror formula and also the magnification formula. And these two formulas are used in sorting out problems relevant to spherical mirrors. So for a spherical mirror, the mirror formula is expressed as this. 1 by V plus 1 by U is equal to 1 by F. You might be wondering what are U and V. In your 9th standard, you might have come across U and V to be the initial and final velocity. But here in this particular topic of reflection, we use U as the object position and V to be the image position. And we already know that F is the focal length. So how to discuss about this object and image position? Let us consider this particular diagram in which MN is the mirror, spherical mirror, whose reflecting surface is facing towards the left. Always by convention, we take the reflecting surface to be facing towards the left so that the object is always taken towards the left of the mirror. And the image formed depends upon whether it is real inverted or virtual erect to be towards the left of the mirror or the right of the mirror. If it is real inverted, it will be towards the left of the mirror, and if it is virtual erect, it will be towards the right of the mirror. And the sign convention goes like this. You might have remembered XY coordinates and max, the Cartesian coordinates, right? So when you take the Cartesian coordinates in your x-axis and your y-axis, and this is your origin, and towards the right of the origin on your x-axis, it is always positive. So towards the right, it's positive. Towards the left, it is negative. So any measurement that is taken towards the left is taken as negative, and towards the right it is taken as positive. So always, since we take the object to be towards the left, therefore the object distance U will always be negative, and the image distance V will be negative if in case it is real inverted, and it will be positive if in case it is virtual erect. See, real inverted image will always be formed in front of the mirror. That is why towards the left measurement irukadunala we have it as what? Negative. But you can see here, for a virtual erect image, it is formed towards the right of the mirror, and distances towards the right is measured as positive, and therefore the V value is taken to be positive for a virtual erect image. Now coming to the y-axis of your Cartesian coordinate, you have got any measurement that is taken towards the top, it is positive, and anything towards the bottom is negative. So always the object by convention is taken upright, that is towards the top. This AB, you can see it is on top of this axis. So the object height of the object is always taken as positive, and height of the image is positive if in case it is virtual erect image. Only for erect image you will take it towards up, and if in case it is a real inverted image, then the height of the image is taken as a negative value, because towards down you are taking it. See, if it's a virtual erect image, over here you are taking it towards the up, and real inverted image, it is towards down, so you take it as what? A negative value. So these are the sign conventions that you have to keep in mind when we are working out problems based on this mirror formula. And the formula is very simple. It is 1 by V plus 1 by U is equal to 1 by F. The second formula that we will be using is that of magnification. What is magnification? It is the relative extent to which the image of an object is magnified with respect to the object size. So the formula for magnification is given by magnification is equal to height of image divided by height of object, or you can say height of image is equal to m times height of object. So this formula, it can be converted into a statement, and that becomes the definition statement for magnification. So the relative extent or the number of times the height of the object has been multiplied by in order to provide the height of the image. So that becomes the magnification. So it is a factor of multiplication of the height of the object. Here we have another formula as well. Magnification is equal to h dash by h, or in terms of v and u solnona, you can have it as minus v by u. So please remember there is a minus sign over here. So magnification can otherwise be written as minus v by u. And here, as we have already discussed, height of the object is always taken as positive because it's always upright, and height of the image is positive for virtual erect image, and it is negative for real inverted image. So we have discussed the signs of u, v, hi, h0. Now let me discuss that for focal length. Focal length, you know, it is the distance between the pole and the focus. In case of a concave mirror, the focus is in front of the mirror, and therefore towards the left you have to do the measurement. So since the focal length is measured towards the left, focal length will be negative for concave mirror. And in case of a convex mirror, the focus is towards the right, and since the measurement is done towards the right, you will have the focal length to be positive for a convex mirror. So these sign conventions along with the values we have to obtain from the given question and then proceed with our problem in order to find the unknown. So we have two formulas in hand, and also we have all the sign conventions, and let's proceed with discussing the problems. Here is our textbook example 10.1. A convex mirror used for rear view on an automobile has a radius of curvature of 3 meter. So first hint that they have given us, it is a convex mirror. So a convex mirror will have focal length which is positive. That is one idea. Now they have given the radius of curvature to be 3 meter. So radius of curvature is capital R, and it is given as 3 meter, and since it is convex, f is positive and also the radius of curvature can be taken as positive, so it is plus 3 meters. And from this you can obtain the focal length as R by 2, which is equal to 3 by 2 meters, and that too positive. So focal length we have arrived from the radius of curvature. The next part of the question is, if a bus is located at 5 meter from this mirror. So the next hint is a bus. It is located 5 meter from the mirror. So the bus is the object here, and 5 meter distance is the object position. So object position U is taken as 5 meters, and always it is taken towards the left, therefore it is always negative. U value is always negative, it is minus 5 meters. Now you have to find the position of image, nature of image, and size of image. Position of image is what? V. You have to find what is V, and you have to find the nature of the image. Obviously you know it's a convex mirror. So convex mirror, you have only two ray diagrams in picture, and whatever be the object position, for sure I'll obtain a virtual erect diminished image. And that is why it is used in rear view. Correct. So for sure the nature is going to be virtual, erect and diminished. And they have asked you also for the size of the image. So size we can relate it with the magnification, and magnification is equal to minus V by U. You are aware of this formula. In this question, they have not given the height of the object in any place, so you can't find the exact size of the image. Rather, how many times it is diminished. That magnification quotient alone we can find. So what is the formula over here? 1 by f is equal to 1 by u plus 1 by v is the formula. Using this formula, I can substitute for f and u and we can find what is v. So once after finding v, we have u and v in hand, which we can substitute it in this formula and find out the magnification as to how many times the image it is formed. So the data has been written over here. The radius of curvature is 3, object distance is minus 5, and image distance and height of the image you have to relate. So here it is, the focal length, it is 3 by 2, and again the formula, from the formula when you substitute, you get the answer for V to be 1.15 meters. So the solving part, you have to take the LCM and solve it proper. In your textbook they have solved it using the decimals, but it's always good to use fractions. So when you use 3 by 2, it becomes quite easier for you rather than going on with 1.5. So the image is 1.15 meter at the back of the mirror. At the back of the mirror, in the sense it is a plus sign, therefore it's a virtual erect image which is formed behind the mirror. Magnification, again as I told you, we have to use minus V by U formula, and using that we have obtained this height of image to be equal to 0.23 times the height of object. So over here the magnification is plus 0.23. In case of mirrors, when the magnification is positive, it means that it is a virtual erect image. And if magnification is negative, then it will be a real inverted image. And the magnification part, we have to divide it into two parts. One is the sign. Using the sign you can deduce these ideas, and using the value over here, see 0.23. If it's a value which is less than 1, then it is diminished. And if it's a value greater than 1, then it is magnified or enlarged. So this is the idea that we can obtain from the value of magnification. So here 0.23 is a value which is less than 1. Therefore, the size of the image is going to be diminished. And if it is equal to 1, then obviously it is the same size. So these are the ideas that you can obtain from the problem given in your textbook. Question number 2. An object 4 cm in size. So height of object h0 is given as 4 cm. An object is always taken upright, therefore it is plus 4 cm. It is placed at 25 cm in front of concave mirror. So 25 cm distance the object is placed. So object position U is always negative, minus 25 cm you will take. Now, the focal length of the concave mirror is given as 15 cm. The focus of a concave mirror lies towards the left, therefore always the concave mirror's focal length value is taken as negative. So it is minus 15 cm. At what distance from the mirror should a screen be placed in order to obtain a sharp image? So at what distance the screen should be placed? The screen is where you obtain the image. So that is the image position, which is V. So they are asking you what is V. Find the nature and size of the image. Nature of the image is virtual erect or real inverted. That part they are asking. And since they have given you, you are placing a screen and on which you will be obtaining the image. So from that itself you can deduce it's a real inverted image. And now coming to the size of the image. Size is nothing but they have given you specifically the height of object. So you can find out the height of the image. So what is the height of image is your next question. So you have to now find, using these data, the answers for V and HI. And for sure you will be knowing the value of V will be negative. So in case of a concave mirror, you can always say, whenever you are going to capture the image on a screen, this is the object and you are capturing the image on a screen. So for sure this is going to be what? Real inverted. So real inverted objects will have their V value to be negative, and also the height of the image is taken towards bottom, therefore height of image will also be negative. So the answer that you obtain for sure should be negative for both V and HI. Let us check whether what the answer you are getting. If you are getting a different sign, then somewhere in your problem you have made a mistake. That part you can analyze. So the same problem, we have got all the data here and the equation for mirror formula, we have it here. Using these two distances, what is it? Object distance and also the focal length distance, you can find what is V using this formula. So we have substituted all these data, and when we solve, we get the value of V to be minus 37.5 centimeter, which is perfectly right because we are getting a negative sign. So now we have to proceed with the magnification formula in order to find the height of the image, which is H dash. Either you can use HI or H dash, either way around. So height of the image H dash divided by H naught is equal to minus V by U is the formula that we have in hand, and I am applying that formula in order to get the height of image to be minus 6 centimeter, and this is also perfectly right because we are getting the negative sign. Since it's a real inverted image, obviously the height of the image has got to be negative.